for this topic, which is 3i, 4 types of relations. Now, some of the things we're going to be talking about today, we've talked about previously in this topic, so it will be a little bit familiar. First of all, relations. A relation is any set of ordered pairs, so any graph that you can make up. Like a function, a relation has a graph. Like a function, a relation has a domain and a range. But unlike a function, a relation may have 2 or more points with the same x coordinate. Because remember, a function can only have one y coordinate for every x coordinate. There are 4 types of relations, and you need to be able to identify these 4 types. The first type is a one-to-one relation. Now, a one-to-one relation will pass a vertical and a horizontal line test. Now, I'm going to draw a diagram for each one of these. A one-to-one relation, a good example of that is your straight line. Any sloping straight line will have a one-to-one relation. It would pass the vertical line test, meaning that a vertical line would only touch it once anywhere where you draw it. And the same goes for a horizontal line test. Okay? So that's an example of a one-to-one relation. A one-to-many relation fails the vertical line test but passes the horizontal line test. That would be a graph, or an example of that kind of graph would be our sideways parabola. Okay, if I was to draw a vertical line, it would fail. Okay, because it would cut twice. But if I draw a horizontal line, it would pass because it's only going to cut once. Now, a one-to-many relation, when you're looking at it, means that for every one x value, there is many y values, or more than one. Many just means more than one y value. Okay, this one has 2 for most spots. So that is a one-to-many relation. The next type is our many-to-one relation. So that is going to look something like, there's a few different options, obviously, but it could look something like this, one of our polynomials that we were drawing in last lesson. That graph would pass the vertical line test. Okay, I could draw vertical lines, it would only go through once, but it would fail the horizontal line test. Now, a way of thinking about that is there are y values. So for y equals 1, for example, there are there's many spots or multiple spots that have the same y value, but there's only ever one x value. Okay, so many y values, only one for the x value. The last type is our many-to-many relation. It fails both the vertical and the horizontal line test. And the example that we're probably most familiar for this is our circle. Okay, it would fail both vertical and horizontal line tests. Okay, a function. We've talked a lot about functions in this topic. A function is a special type of relation. It has special criteria. A relation that passes the vertical line test is called a function. Okay. Now, not all of the relations that we've been talking about up here pass the vertical line test. The only ones that do are our one-to-one relations, so those ones are functions, and also our many-to-one relation. So those ones are also functions. Okay, so let's have a look at our examples today. These questions are a little bit wordy. Remember that the main idea of this section is that you can identify the different type of the 4 relations. You can identify them if you have the graph. Now, the tricky part with these examples is that we don't have a graph to start with, so we have to try and work out what a graph would look like for each one. So in example number 1, it says, in a firm of 10,000 employees, a database records the postcode, which is going to be the Y values, that each person, which is an X value, has nominated as their home address. So explain why this is a function and whether it is a one-to-one or a many-to-one. Okay, let's see if we can draw that. If it says my X value represents each person, let's draw a little, I'll make this a bit bigger. We're going to draw a little graph over here. On my X-axis, this is going to represent each person. And so each employee, because this is a firm's 10,000 employees. We're going to have person 1, we're going to have person 2, person 3. We'll give them all a number because that makes it easy to draw a graph. And each of those employees would have a postcode. Now, I'm not going to write 2250 or those kind of more specific postcodes. Again, I'm just going to call them, we have 1, 2, 3, 4, many more different types of postcodes. Now, person 1, they might have postcode number 2 here. Person 2, maybe they have postcode number 3. But what we hopefully realize is that each person should only have one postcode. Now we're going to assume that people, these are adults, so they're employees. They're not coming from split families where they might live at 2 different addresses. We're just going to say each person has one place where they live, these adults, because they're employees. So person number 3, maybe they'll have the same postcode as person number 2. And maybe person number 4 has postcode number 1. Who knows? We're making up some data here. But what we can see is that each person only has one postcode. So that way it's going to pass the vertical line test, meaning that it is going to be a function. But if we do the horizontal line test, we could see that it is possible for 2 employees to have the same postcode. And especially when you have 10,000 employees, it would be highly likely that people in the one business would have multiple people coming from the same area and having the same postcode. So we need to try and explain this because this is an explain question. So first of all, it's a function because each person can only have one postcode. So let's write that down. Okay, but it will not pass the horizontal line test as there is likely to have multiple employees having the same postcode. But it will not pass the horizontal line test as multiple employees will have the same postcode. Okay, so we are asked to determine whether it is a one-to-one or a many-to-one relationship there. So it's obviously not a one-to-one, it is a many-to-one because we have many y values that are in a line here, multiple y values in a line. So therefore, that is going to be a many-to-one relation. Part B of that question, what change may there be for a smaller firm that only has 10 employees? If we only have 10 employees, it is possible that all the people could come from a different postcode. So if that were to happen, that would make it a one-to-one relation. So that's a possibility. Let's write that in. It is possible for 10 employees or for all employees to have a different postcode making the function one-to-one. Okay, question 2. Many people, which are going to be our x values again, live in the suburb of Erina and they own a pet, which is going to be the y value. What sort of relation is this? Let's see if we could have some kind of representation of a graph for that. On our x-axis, again, we're going to have our people or person. So we have one person, 1, 2, 3, 4 again, keeping it simple. And our y-axis is going to be the pets. So let's think for a moment that we are walking down one of the streets of Erina and we're door knocking on the door and asking people about their pets. So we knock on door number 1 and that person has a dog. Okay, so we go, that person has the dog. They have a dog called Bob, whatever the dog name is. We go to door number 2 and that person also has a dog, but it is not the same dog. They have, obviously they're not having the same pet, it is a different dog. So they have another dog up here and maybe they have a rabbit, who knows, they might have something else as well. So they might have 2 pets. Now that would then seem that it would be that because each person, all these different pets, we'd never have any double up. However, what happens if we ask person number 2, maybe they have a brother, and we ask them the same question? They are also going to have the same dog and the same rabbit. They might also have the same pets because they are living in the same house and they're siblings. So therefore, when we look at that, what kind of relationship does that have? Well, looking at our vertical and our horizontal line test, it would fail the vertical line test because people can have more than one pet. It also fails the horizontal line test because siblings can share their pets. So that means that this is going to be a many-to-many relationship. So I'm going to write down here as an explanation, it fails the vertical and horizontal line test, and therefore it is going to be a many-to-many relationship. Part B, we're going to put a little bit of a twist on this. It says the council registers each pet with only one owner. What sort of relation is this? If the pet can only have one owner, it means that we are only taking the person who owns the dog, not each person in that house being listed in there as the owner of that dog. So we wouldn't be counting the siblings as owning the same pets. That would then mean that we pass the vertical line test. So pass vertical line test. Oh, sorry, wrong way around. It does not pass the vertical line test. We still have people that can have 2 pets there, so it does not pass. Let me fix that up. Does not pass the vertical line test. The one that it does pass is the horizontal line test, because we now no longer have multiple people caring for the same pets or being owners of that pet. So it does not pass the horizontal, does pass the horizontal line test. So So we need to give that a name, something that passes the vertical line test but fails the vertical line test but passes the horizontal line test is going to be the one-to-many relation. All right, that is it. You finish your last exercise, which is 3i.